We are an enabling platform working on commercial ventures to really facilitate the acceleration and drive toward a net zero and circular future for chemicals and plastics. Incubated originally at the World Economic Forum, where we operated for a number of years. And since 2 years now, we have spun off into an independent association. Our members include some of the world's leading chemical and plastics producers and recyclers. And we are really working to build these commercial ventures that focus on reducing emissions, increasing circularity, and pursuing alternative feedstocks. And as an incubation platform, we guide our members through this 4-step process to take them quickly from ideas and concepts to collaborate and on the challenges that cannot be solved by any one industry or any one player alone. Prioritize those, forming working groups and pilot projects that are then spun off into new business ventures. So we're one of our most, let's say, proud projects that we have been working on over the past year is the Automotive Plastic Circularity Pilot. And with that, I will turn it over to Kai to take us through what this project is about.
Thank you, Amanda, and also welcome everyone from my side. Yes, with this, we turn to, at the beginning, an overview on our Automotive Plastic Circularity Pilot. To give you an intro. So you see here the goal, what is the main goal of the project? We are evaluating the technical and economic feasibility to recover plastics basically from end-of-life vehicles and then to use it as a feedstock in the recycling processes. And when I say technical, what do we mean by this? So it's basically starting to look at, can we remove plastic parts from the cars? Can we then also process them? Can we shredder them, sort them? And which yields and purity levels do we achieve at the end? And the economic feasibility is then, at which cost basically can we remove the plastics and generate the feedstock. So you see here at the bottom the companies that joined our pilot. We have 8 companies, broad range from the chemical industry, also from the recycling industry, and it's just great to have these different perspectives in the pilot and bring the pre-competitive know-how together to achieve together better assessments. And the reason why we're conducting the pilot, you see that here in the middle box, the 2.5%, that's the share of closed loop plastics in automotive today in Europe. And that is below what the regulation is targeting with moving towards more 6%. And it's also telling us that the ecosystem and the industry that looks at recycling of plastic is rather at the beginning of its path. What makes our pilot special or unique? I think 2 things. One is, so in the pilot, we're not starting with the automotive shredder residue, which can be contaminated and is difficult to separate in streams. But our hypothesis was that if we group dismantled parts and run them separately through the recycling process, that this will lead to better yields and also better purity levels. So that's one. And the other thing is, whereas there are quite some activities of disassembling car parts, for example, for reuse or remanufacturing, we're bringing here together the perspective of the chemical industry with the target to really use the plastics to generate new material, new products from it. So I think that's the 2 things that make the project special. And how we structured the project, we will come to that on the next slide. You see here an overview of the steps. 2 things to mention at the beginning. First, we, in this first project phase, looked especially at the technical feasibility, and we used for that also the existing infrastructure. And the second thing is that we conducted our pilot really in real world on the ground to generate the learnings. So we have really a material flow oriented project, and you see here the key steps. So we started in January 2025 by sourcing actually 100 ELVs. You see also the partners here that supported us along the journey. And these ELVs represented a typical country mix. You had different brands, different models, different sizes. And then we moved these cars to disassembly with a partner here, Glasper, in the Netherlands. We targeted 35 car parts and disregarded also some parts because they cause danger, for example, in the follow-up processes. For example, the fuel tank we didn't consider. And then in the next step, what I mentioned on the last slide, we grouped these car parts along the target polymer compositions into 22 groups and run them separately through the process. Yeah, and the first step was here shredding that we conducted in Germany. And then we had a two-step sorting approach. First, we had a sorting trial of the material that we achieved to look at the purity level and also to be able to conduct some changes in the sorting process, some improvement steps before we then conducted the full sorting of the main fractions. And that's where we are right now. So we're waiting for the final results from the sorting of the main fraction. And these fractions will then be shipped to the member companies who will conduct the recycling tests and feedstock recovery. And here also we will look at a broad range of recycling technologies in the field of chemical recycling, but also mechanical recycling. This step is also done through the competitive nature by each company then individually. Yeah? And here on the project deliverables, I mentioned already the first two, but across these route, we generated also a lot of qualitative learnings on the process, how to improve the process in the future. So that's definitely also an outcome of this first phase. And to give you a little bit of flavor of how the first step, the disassembly, looked like, we brought a little video to show you. And can move to that now. What you see here is the dismantling process with the Scorpion excavator crane. The crane is normally used to dismantle metal parts from cars, but we used it here for plastics. You see also in the background the big bags where we sorted and separated the different car parts that we collected. And I would say it worked quite well so that the crane could also take out plastic parts. You see that here in the door to separate the plastics from the metal part, just to give you an impression on that. And with that, to have an overview on the general learnings across the steps that we had, I hand over to Lisa.
Thank you, Kai. And hi, everyone, also from my side. Could you move to the next slide, Amanda, please? So as Kai already told you, we have completed dismantling, shredding, and sorting, and we are happy today to share our first key learnings with you that we have reached these important milestones. So first of all, the fantastic thing that we have discovered is that our hypothesis of using the excavator to improve dismantling proved to be quite successful. So we have shown that this was really feasible, and we were able to remove over 50% of the plastics per car across all of our target polymers. And then we were able, when we looked at the whole process, to kind of categorize and create this categorization system of the car parts, and we grouped them together by effort and complexity of dismantling and shredding, and we will now use this information as a basis to create the business case for the different groups. For the shredding, it was also very successful, and Matthias will go into more detail about what we have discovered here. But of course, when we are looking at the material streams from dismantling up to sorting, what we found is that we were facing some losses in the material, just mainly because due to contaminations or paints that had to be removed, multi-material parts that we could not use as is, or just because parts are being glued together and so on and so forth. When it comes to the target specifications, or another big learning around target specifications, is that we have discovered that currently, for the recyclates, there is no clear defined target specification available. And this, of course, poses a challenge for the whole system. And we are really working or aiming to work here to improve this and work together with the whole value chain to define better and create these target specifications to then also optimize the whole process. When it comes to looking at the business case levers, one learning that was was maybe not so surprising is that currently the dismantling of end-of-life cars is really targeted to take out the value of the metal, right? So it's really focused on metal recovery. And currently, we do not see that plastics are, recovered in the same kind of rate and with the same kind of value. But coming up with the new regulation of the end-of-life vehicle directive and also the interest from the industry to closing the loop, we also believe that this will change in the future. And if we are working together across the value chain, that there can be really value created here for recycling the plastics. And another learning when it comes to a more business case related topic is that, yes, currently plastics removal is still costlier than using virgin feedstock, just because we have to go through a lot of steps and the process is not yet optimized. But as Kai already mentioned, we did a lot of trials on the ground. We were really looking into it. And we identified a lot of opportunities where we can optimize this whole process and where we can also, positively impact the cost of it. Amanda, will you please move on? All right, now I want to share some more insights into what we have learned during the dismantling trial when we were on the ground. And one thing that was really fantastic for us to see is that some of the plastic parts, they can be collected quite easily. And this is mainly the plastic parts that are connected around the metal recovery of, or the metal dismantling of the car. So for example, for metal dismantling, they will take out the copper wires. So we will have easy access to the connectors that are attached to those. Also, in preparation for dismantling of the cars, a lot of the plastic parts are being removed. For example, the underbody shield is being taken out to get access to, for example, the motor to drain the fluids and these kind of things. So access to the underbody shield is quite easy for us. And the wheels are taken off as well, so wheel covers can be accessed also nicely. So this is really fantastic. Also the exterior parts like the bumper, mirror housing and so on, it was quite easy to recover with the crane. And this is very positive for us. We are now going to analyze it further, as Kai already said, and to really look into the technical feasibility of this as well. Next slide, please. But of course, where there are positive findings and easy things, when things are going too easily, there are always some challenges as well that have to be faced. And it was the same case for us. There were some plastic parts that were, using this approach with the excavator that were a bit more challenging to remove. One of the examples is the rear lights. So the rear lights are mainly made out of PMMA and other polymers. And the challenge that we faced here was that the excavator, it doesn't have a pressure control, and PMMA is actually quite brittle. So when the crane operator removed the rear lights with the excavator arm, the PMMA would break, it would fall to the ground, and then it was very, very difficult to recover for us. So thanks to the ingenuity and adaptability on the side, we actually came up with a new way of extracting this kind of polymer during our trial. And you can see here on the left-hand picture that the guys actually, manually removed the PMMA lens from the rear lights. Of course, we understand this is not the optimized process yet, and this is not how it hopefully will look like in the future, but it will give us the opportunity to look at the material and still assess purity, quality, and feasibility for recycling. Another more challenging part or group of parts was really the under the hood parts. And that was mainly due because they were sometimes really difficult to reach. Sometimes they were glued in or screwed in. So it was very, very difficult to extract them. But also here we are seeing that, okay, even though we have faced some challenges, this is not the end of the story, and we will not directly rule out these materials for recycling or a closed loop approach. Because when we are looking at feasibility, technical and economic feasibility, there's always the optimization potential that we already talked about a little bit. And of course, we will have to factor in other things like purity, quality of the material, volumes that can be recovered, the ease of sorting efficiency and how easy the material is to recycle, and also, of course, the market requirements. So here we are really working or thinking of working on optimizing the process and then re-evaluating. And we are also expecting in the future to have, for example, more automized dismantling possibility to improve recovery of more challenging materials. Next slide, please. The last kind of group of car parts I want to talk about are the ones that are attached to metals. So here I have two examples that I would like to discuss with you. The first one is really around seats. So you can see here on the picture we have the foam cushion, and then that's really in the structure of this metal frame to give the shape to the end of life, to the seats. And for the end-of-life cars, it was quite easy to dismantle it, but then it was a little bit more challenging when it comes to shredding because of the big metal pieces. And I think Matthias will talk a little bit more about this in his presentation. So I will not give away too much here. But talking about the dashboards, we also face that, of course, not only do they contain metals, which makes it a bit more challenging when it comes to shredding, but also we saw that they are a wild mix of 1-component, 2-component, and 3-component dashboards. And we currently, for end-of-life cars, we do not have any data available which kind of brand or model uses which type of dashboard. So that made it quite challenging because it's also a material mix, and further processing was then a bit more tricky for us. And when it comes to the dashboards, we have also seen that further pre-treatment, especially for the 2K and 3K dashboards, is required to separate the multi-material mix. But here, most of the processes are also not on big scale development yet, so they're still, not really working for end-of-life vehicle components, and there are still some pre-treatment and process development that has to be done. So to close the section, I think we have learned a lot during dismantling. We have understood a lot of things that can be improved, and we will now use all of these results to really look into the business case and see how we can deal with it. And this closes my section. I will hand over to Matthias.
Yeah, thank you, Lisa, and hello everyone also from my side. As indicated by Lisa, let's talk about shredding and the shredding challenges in automotive plastics recycling. Some parts like the bumpers or the skid plates, or sometimes we call it underbody shielding, are rather easy to shred. So these are quick wins for the recycling. They can directly go into the further process with rather minimal effort. But not all parts are this simple. So the carpets or the airbags you see here on the right-hand side, for example, cannot be shredded with standard equipment. They require alternative technologies or special treatment. Yeah, so the airbags are incredibly stable, let's say, and rather cause problems in standard shredding processes. This means we still need to develop new solutions for these components. And in general, I would say it's important to identify which parts are easy and which are difficult early in the whole process. By focusing on the easy to shred, like on the left-hand side parts, first, we can quickly increase the recycling rates. At the same time, we also must think about investing in research for the more challenging materials like the carpets and the airbags, for example. So next slide. Amanda, please. So now let's have a closer look at parts that require metal shredding. As you know, some of the components of, for example, steering wheels and seats are attached to metal. For these, metal shredding is necessary to separate the plastics from the metal. The good news is that this process yields rather high quality for some plastics fraction. You see them here on the left-hand side, like the steering wheels or the seats. And there we see good separation and recovery rates for the plastics we can obtain from these parts. However, not all parts respond that well. Plastic or foam parts from suspensions, for example, or the engine on the very right-hand side are much harder to separate. The complexity of these assemblies makes plastics recovery more difficult, which was especially to allow me a special note for us as BASF, supplying a lot of polyamide to the market that is attached to the engine was a little bit of disappointing, but that is something we also observed on the ground, that some of the cars, and we've chosen deliberately rather old cars, 15 to 20 years old, not all had, for example, a plastic air intake manifold at that time already. Yeah? So it might improve over time. However, these results highlight the need for targeted dismantling strategies. So we need to put some thoughts and effort into that, how to improve to get these materials accessible as well. So, however, we should focus on the parts where metal shredding is effective, while we, on the other hand, should also continue to explore better methods for the more complex assemblies, like the engine, for example. Amanda, next slide, please. So let's have a look at the big picture of the whole car. Our data shows that over 80% of recovered plastics parts can be easily dismantled and or shredded. So that's what we think is a strong foundation for scaling up recycling. As you can see here, we clustered all modules that were mentioned by Kai in the beginning into 4 groups according to how well they could be dismantled and shredded. For example, the headlamp systems on the upper left side are easy to shred, but rather difficult to dismantle, while the bumpers are both easy to dismantle and to shred. On the other hand, lower left corner of the diagram, Jounce bumpers are neither easy to dismantle nor to shred. And the carpets, for example, are easy to dismantle, but challenging to shred, as we saw before. So this categorization helps us to prioritize our efforts. So we should focus first on the upper row, I think, on the easy categories to achieve quick wins and quick progress. Next slide. So let's dive into a specific example, fans and shrouds, which are part of the cooling system of the car right in front of the engine. So our first sorting samples show promising results, as Kai mentioned. So we started with understanding how do the fractions look like. After dismantling, about 60% of the material is polymer fraction, and while close to 40% is only dust and waste, so we didn't process further. So within the polymer fraction, we see high quality polyamide and PP fractions. Most of them, of course, due to the mechanical requirements, are containing glass fibers, which is another topic then later on in the recycling process. This means that with the right processes, we can recover significant amounts of pure plastics fraction from these parts. However, there's still room for optimization. We need to further improve sorting and processing to maximize at the end both yield and quality. Now come to the next slide. So the most important question probably all of you are interested in: what will make plastic recycling in automotive truly viable at the end? First, we need to optimize, scale, and digitalize our processes. This includes improving the design of dismantling equipment. You saw the excavator in the movie. Optimizing on-site organization. Also, you could get a glimpse how we positioned the big bags, for example, as well as optimization of dismantling and shredding. Centralization is another key lever. Large-scale recyclers can help us achieve economies of scale, and the chemical companies like we, BASF, or the colleagues from Covestro or Mitsubishi should be embedded in the broader ecosystem. And I think we made a first step here to bring our know-how also in this pilot. Digitalization and automatization are crucial. Using databases and robots for smarter disassembly will boost the efficiency and the consistency. Finally, we must combine recycling with other R strategies, namely reuse, repair, refurbish, and remanufacture, because this maximizes value and reduces the waste. By pulling these levers together, we as a team here, we believe we can build a viable business case for automotive plastics recycling. And next slide. Let's close the first part of today's seminar with the next steps for phase 1 we are still in. Our immediate focus is to finalize the sorting and the recycling tests conducted by the chemical companies in the project. All outcomes produced throughout the year will be consolidated. This will give us then a comprehensive view of what really works and where we need to improve. And next, we'll prepare for phase 2. But before we talk about phase 2 in more detail, I hand over to Amanda for a first quick round of Q&A.
Over to you, Kai, to explain a bit about where we go from here.
Exactly. Yeah, Matthias mentioned it already, right? We are preparing now already the phase 2 of the project. That's about to start in February 2026. And we wanted today already share with you the direction in which we are thinking. Yeah, it's not detailed out yet, but we want to share that early with you, also to get your feedback, to see also where your interest is in these options that we have here. And I briefly go through. One thing we're thinking for the second phase is to have a component-specific case, right? I said we looked at 35 different car parts, and the idea would be now to choose 1 or 2 and to really create a viable business case around these parts. And the parts can be either because they're high volume or easy to dismantle, but they can be also parts that have a high value, and we would select and then create a pilot around this. So this is A. Then B, option B is much broader. That is crafting a blueprint how to scale up the recycling of plastics for end-of-life vehicles in a certain regional scope. And creating a roadmap, what is needed, what needs to be implemented to get there, to really bring the cost for the recycled material down. Matthias shared the overview, what we have in mind. This would then need to be incorporated in this future setup. You can think of it as a little heat map where we say what are the highest lever to reduce, to bring costs down and to start with it. And of course, it has also this perspective that we need to look at the existing recycling setup that we have in a certain region, and then see how can we best integrate the activities, right? Topics like consolidating volume streams, piggybacking we had on existing activities for metal recycling. Can we then there add, for example, plastic recycling where it makes sense? So that would be map out a broader roadmap how to scale. And then C is looking for the future, for the design of future parts, design for recycling, dismantling. We had quite some learnings, right, that parts were difficult to dismantle. We heard it today, or that we had also a variety between brands and models. And that stream would look at defining guidelines, how to design products that they are easier to dismantle, but not only that, but also to recycle. So also for better shredding, for better sorting. And for that, we need to consider different things. Of course, the requirements, the design requirements for a part. Also, how do we match that with existing and potential also future recycling processes? Yeah, with the recycling landscapes, regulations play a role, and of course also here to look what is economic feasible. And also here we would pick one or two components and create a case around that. And for all the three options, we would also we plan that we run that similar to the first phase, that it's really a real life experiment where we run the pilot on the ground, because we had such good experience with generating learnings in this way. And this is an overview and the directions we're thinking, and we wanted to invite you now and would be interested. Which options do you see for yourself interesting? And we wanted to ask if you can put that in the Q&A. Of course, also any feedback on these options, any questions you might have, and then we can have a discussion around that. Thank you.
Thank you, Kai. So yeah, just if you have any other comments, feedback on these different options, which one seems interesting and relevant for your organization. While we're letting people comment there was also a question around the easiest part of the closed loop project. And Matthias, you mentioned the bumper. Any other feedback on kind of the easiest part of the project, or what really worked well? Maybe Lisa, you shared a little bit on the initial learnings. Anything you want to share as well on the overall feedback on the project?
Yeah, I think when it comes to the project results, we have already shared a lot. I think what I would like to highlight is that the collaborative spirit, that was really also, very fantastic to really work in that consortium. I would say that's really also a highlight of the project, even though it doesn't have to do really with the results that we gathered during the project, but without that innovative spirit and great collaboration, I think it would have not been possible to come so far.
Yes, and definitely this was, I think, one of the things that the Global Impact Coalition was able to do when we bring together all of these different stakeholders. And I think it was really inspiring to also see how so many different companies can come together and to connect really the beginning of the value chain with the end of the value chain and really try to close that loop for circularity. We just have a comment here around that option B would be interesting, with 1 or 2 deep dives of option A. Again, any other people that would want to comment here? And just to clarify too, we're happy to have ongoing then conversations and in the next steps as well. Just wanted to give a moment if there were any other feedback or questions also around the next steps and what those could look like.
Maybe one thing, Amanda, that we can also add is that at the moment, these are, of course, ideas, and we're happy to reshape them or combine them as, to finalize the project planning as well.
Yeah, sorry, I see one more comment also, that A, because it handles the current recycling situation the best. C would be very complex because it would be another project rather than only a phase. As you have to kind of redesign and develop components from scratch and validate them in the end. But so thanks for sharing your thoughts there. Another comment seems some of the challenges are design related. So for me, option C, to educate OEMs, and I'll go to the next step. And yeah, as Lisa also said, the idea would be we don't necessarily do one or the other. It could be multiple projects. So then maybe I think with that, in the interest of time, I'll go to the last slide here. So Kai, you want to just share this one? This is me sharing this one.
It's you, but I'm happy also to.
Okay. Yeah. So sorry, so this one basically just to clarify next steps. So please reach out, send an email to me. You should have received the calendar invite also from my email. So amanda.martin@wearegrc.com. And the idea then is to have further deep dive discussions one-on-one. And we would like to really onboard interested partners until December, ideally. Of course, it's not closed then, but we try to move fast so that we can progress. And there is an important to note that it would need to be adhering to the GIC regulations and paying the entrance fee as well. This is really the outline of the plan for the next steps. So we would like to kind of kick this off in January with a presentation in Davos, and then kicking off activities in February of 2026. So moving fast, because there's a lot to solve and little time to do it, and we would really welcome your engagement and collaboration on this. Please feel free to share any further comments or questions. And again, we have recorded this, so we will be also sharing that in case some people couldn't make it.